So we're going to cover up the differential of trigonometric functions in three parts. The first part being if you're simply given something like sin x, cos x or tan x, and then we'll advance it up. So first of all, you need to rectify the basic differentials of these trigonometric functions. So we have three: sin x, cos x, and tan x. So going forwards, we have the differential of sin x as cos x. Then for cos x, going backwards, let's make this plus and this minus. We have, you don't need to remember this. It's only how I remember it. So the differential of cos x is minus sin x, because I think of it as we're going backwards. Then the differential of tan x is unique. It's sec square x. Well, sec square x is usually 1 over cos, but yeah, alright, we'll get to that. So for now, only remember that the differential of tan x is sec square x, and you don't need to advance things up. I repeat, you don't need to advance things up, and you only need to know that the differential of tan x is sec square x. Moving on, what if we have something with x, or it's a function? So in that case, we'll keep things simple. We learn it as, let's say we have a trigonometric function, and we have something inside the brackets which, let's say, is y, and we might have something before which in this case is 1. So if we were to differentiate this whole thing, we'd have the differential of a trigonometric function. The thing inside the bracket remains as it is, x also remains as it is, and we are going to multiply this whole thing by the differential of what's inside the brackets, which in this case, we're going to multiply it by the differential of what's inside the brackets, which in this case is going to be y complement. So I repeat, we have something before the trigonometric function and something inside the trigonometric function. If you were to differentiate a trigonometric function, it's going to be differential of the trigonometric function. Thing inside the bracket remains as it is. The thing before remains as it is, and we are going to multiply this thing by the differential of what's inside the brackets, in this case y complement. So we better understand things. Let's take a few examples, a few generalized examples. Let's say we have sin ax, and we have nothing before sin x, it's going to be 1 obviously. So the thing inside the brackets remains as it is. The differential of sin x is cos, and we're going to multiply cos ax by the differential of what's inside the brackets. Thus, my bad, we have y time a cos ax. A cos ax. And then we have cos ax. So the differential of cos is going to be minus sine, and the thing inside the brackets remains as it is, multiplied by differential of the brackets. We'll end up with minus a sine ax. That's it. Then we have y is equal to tan x. So the differential of tan is going to be sec square, and the thing inside the brackets remains as it is, multiplied by the differential of what's inside the brackets, that's a. And thus our final differential is going to be, in generalized form, a sec square ax, if we have a linear inside the brackets. And then moving on to our last set of examples, y sine, and we have a function, whatever function it is. So the steps are going to be the same. The differential of sine is cos. What's inside the brackets remains as it is. In this case, fx multiplied by the differential of fx. Let's tidy things up a bit. Oops, my bad. Alright, so we have y is equals to cos fx. So in this case, we have y prime, the differential of cos, that is minus sine, fx remains as it is, multiplied by the differential of fx. So the prime is going to be here, my bad. The final differential of this whole thing is going to be y prime is equals to minus f minus the differential of f of x, which you can write like this, and sine f of x. Then our last example, y is equals to tan fx. The differential of tan is sec square. Fx remains as it is. F prime x. And then y prime is f of x sec square f of x. And this is essentially all. First of all, we need to rectify the basic trigonometric functions and their differentials. Then moving on, what if we don't have it in basic form? What if we have a function, a linear function, or a quadratic, whatever? How do you deal with those? So we moved up step by step, and we also covered up differentiation of trigonometric functions. If you need numeric examples, usually you don't need them, but the concept is going to be the same. Let's say for cos, I have cos 2x squared. In this case, the differential of cos is minus sine. The thing inside the brackets remains as it is. The differentiation of the thing inside the brackets is 4x. And thus I'll end up with minus 4x sine 2x squared. And finally, tada!